So as you heard, I'm a professor at the University of Michigan. I've been there a long time. You can probably see it from the gray hair. I teach in earth sciences, and I teach in environmental sciences. I'll give you a bit of background where it comes from. So my research area is in earthquake hazards. And the other area that I work in is what I'll talk about today, is about societal resilience, how society adjusts to the changes that are before us today and in the near future and in the coming years. I said I'm a professor. I've done all the things that a professor is supposed to do. I profess, obviously. I have done administrative jobs. I'm old enough now I can go back to being a professor. But I also run a journal that's called Earth's Future, where we publish a lot of research on trying to understand large-scale patterns of the evolution of our planet. And that's kind of sort of ties in very well with the stuff that I'll talk about today. What I decided to do was I give talk like this to different groups of people. I take alumni on trips around the world, and I give talks like this. And so I treat you similarly to alumni of Michigan, even though you may not be an alumnus of Michigan. I give you a general talk, but also I won't stay away from giving a bit of the science behind there. The slides are there, they're not on the test. There's no exam afterward. But the slides are there to remind me to make sure I make the points I want to make. And so if you see text on the slide and you think what this is about, it will be there. If I don't mention it, don't worry about it. It's my sort of my way to remember to say the things that I need to say. And that's sort of how things hangs together. What we'll do is we'll look a bit at a couple of commentaries about the setting of our planet, basically what it's like for us to be on this planet, what's special about the planet. Then we'll look about the role of humans, in particular the numbers of humans and demographic trends. I'll give you a bit of insights about what major trends we're seeing in demography, in people dynamics as it takes place, and what the future holds there. We'll look a bit at the needs that we have as humans, which of course is what will shape our future. The needs is what drives us forward in many ways. And then we'll look at some of the impacts that we'll have to deal with as the planet is busier, but it keeps ticking as it always has for a very long time. So we'll look at the impacts, and I'll give you a bit of a flavor of the various impacts. And at the end, depending on time, we'll look a bit at possible way to think about what it means for us individually, but also as humans. There's about 18 or 19 slides, and I do that mostly so there's time to actually have some dialogue as well. If you have questions, please let me know and stop me along the way, that's fine, but I also think we should have some time at the end to have a bit of a conversation about some topics that I cannot touch on, because it's an awfully big topic. It's the human era. It's about us, which is always good. Whenever I talk about this, everybody's interested because it's about themselves. It's much better than something abstract. It's about us living on our planet and how we are basically utilizing what the planet has to offer. And I have to figure out how to do all the technology things right. Yes, I do. Let me get this slide. There you go. So the first thing first, and you have to appreciate, if anything you take away from this is how incredibly lucky you are. We are living on this planet Earth, and it is just right for us. It is absolutely perfect. It is not too hot. It's not too cold. It has an atmosphere we can breathe. It's just perfect. And either we found this because it's the place for us, or it found us. And I would like you to take the point away. The planet found us. We did not find the planet. So we adjusted to our planet, but it is just right. It's actually kind of amazing as a planet. If you hear about NASA looking for other places to live, they look at a planet like Earth because there's a couple of characteristics. Probably the most important ones are not the oxygen in the atmosphere. That you can do different things with. But it's the fact that we have water, and water in a liquid form. And what makes our planet incredibly special, and it makes it so unique to us, is that we have liquid water, H2O, in a liquid form. We also have it in a gas form. We have it in a solid form. We have it in all three typical forms. But the water phase of water is critical for the evolution of life. And that's exactly there because we're at the right distance from the sun, not too far away. It would be too cold, too close, it'd be too hot. And actually, if it wasn't for the atmosphere, what we have today, if it wasn't for the greenhouse gases, which you hear a lot of bad things about, but they're very good for us as well, we'd actually always be in a frozen planet as well. It would always be frozen here. We're living just right at this planet. And I want you to remember that, because as we tinker with the planet, you have to realize we are not very resilient. We have exactly adjusted to the way the planet is. If you change the planet, we have to change with it, because that's how we got to be the way we were. And so this idea, we call it the Goldilocks planet, because it's just right. Not too hot, not too cold. Not too large, not too small. That has all kinds of other benefits. If it's a large planet, it has different properties than a small planet. We won't get there. But it's really kind of amazing that we live on this particular planet. But water, that's really one of the things that, is the point. Water is one of the things that we have that makes it very unique. If we look for other planets to live on, we look for those conditions, not too far away, having the opportunity for water as we go about. So remember that first pass. We're lucky to be on this planet, and there's really no planet B that we know of yet. This is what we have, okay? So the other thing that you want to get a sense of, and that's why I'm not a biologist, but I'm a geologist or a biogeologist, whatever you want to call that term, is that we have the concept of time to also put in your mind. You and I pretty much live in this concept of a couple of centuries we can figure out, maybe a few thousand years is sort of in our thinking. But for our planet, that's nothing. We have to remember that our planet has been evolving for more than 4.5 billion years. That's a lot. Well, a billion used to be a lot. Now everybody talks about billions. But a billion is nonetheless a lot of years. And our planet has been around for quite a while, 4.5 billion years. So has our sun, so have the other planets, all about the same time they got formed. What matters there is that we are some of the products of this planet 4.5 billion years later. We're not the only product, but we are part of that evolution of our planet. And if you look at this spiral that starts somewhere over here, is where we begin with the formation of the Earth, which we're not going to talk about. It's a whole different story. It's an interesting story, but not the topic of today. But as we sort of start with the beginning of the planet, it took a very long time for complex organisms to make their appearance. It took about 4 billion years, in fact, for complex organisms to make their appearance. And we are a complex organism, in case you wonder what a complex organism is. If you didn't already know that you were a complex organism. But we had simple life forms. I can't see very well on stand, so sorry if I have to crunch on you a little bit, but I can read it from here. So we sort of start off with simple life forms, but they're not that simple anymore. They are complicated cells. They have different properties, different behaviors. And then with time, that's what I'm afraid of. With time, we start to see these life forms getting more and more intricate, more and more complicated. You can touch on of course, the dinosaurs is always a good one. People are always infatuated by dinosaurs and stuff. And as we go around, we get closer and closer to where we are. And here we are, sitting at this edge right over here. Sometimes I jokingly say we're sitting at the abyss. We're staring down our own future, right? That's not the case. It's just where time stops. It's where we are today. And we are part of that evolution. And just to make sure you realize, these guys thought they were number one. These guys thought they were number one. We think we're number one, all right? And so all the animals at some point in time thought they were number one. So maybe a little humility in our case, realize that maybe we're not number one. We happen to be a very evolved species, but every species before us thought they were number one. So we did the dinosaurs, and you know what happened to those guys. Never heard much of them since anymore. So the point is, we had a lot of time to get to where we were. And that's kind of the beauty of understanding of how the evolution of the planet. But we reached a time now whereby this species, you and I, this species actually is changing parts of our planet so much that it actually, we start to talk about it being a different geologic event, meaning that we are seeing so many changes take place because of the presence and the behaviors of humans that we actually would be able to identify that as we did other events in time that we call geologic events that shaped the surface of the Earth, that shaped perhaps the life forms of the Earth. Well, we won't have time to talk about extinctions, but it's one of the topics we can explore maybe later on. The bottom line is we have reached the stage where we think that humans are sufficiently large driver as a species on the planet today that actually it's starting to adjust the planet to our needs. But remember, we don't have much tolerances in those needs, so be careful before you change the thermostat and the like. But we are changing a lot. The roads that I drove, houses, the infrastructures, everything else, that's all what we do, all around the world, wherever you go. And so we call that, therefore, this new era, we like to call it the Anthropocene. Anthropo from humans, and scene, because geologists always have the word scene at everything at the end of a geologic era. So the Anthropocene is that concept that humans are making very, very large changes. And we'll look a little bit about these changes, but I also want you to always keep in the back of your mind that you want to make sure that your changes don't control you. That we control the changes. In other words, we are living on this planet, and the planet gave us the environment that we liked to evolve where we were, but as a consequence, our tolerances are low for change. I always give the anecdote also, it's like our eyes, we look our eyes, we look at the slides. Our eyes are just the way it evolved because our sun is the way it is. We live on another planet, your eyes would have done a very different job. We adjusted to our planet. But today, we're starting to tweak the planet in ways that we want to think a bit about, what the practicality of those particular changes is. So why is that? Well, humans is a species, and like there are many species, we are the top dog, not because we're hunters, but we're very clever. We're not very strong, but we're very clever. We're very clever overall in all these things that we do. But we're the top species because we essentially control pretty much all the other species on the planet. We can force all the other species to do what we want. That's essentially the top predator, even though we don't hunt, at least not in the way that other animals used to hunt as they went about. But what has changed is not that we are a species that is very high on the trophic level. We're also, in a lot of us, there's a lot of us around. We basically are making our presence known on the planet by our sheer numbers. Since we are the top species, there's really nothing stopping us from procreating. In other words, humanity can grow and grow and grow because nothing really is stopping us. You always see the occasional animal that attacks us, but there is 3 billion or so of us around. And so it's not really that we have to worry about a lot of animals that are taking us down. We can just do what we want, get offspring, and that offspring can just go on and live on. And as a consequence, we have a busier and busier planet with humans. The top species has no predators. We are that. That's why we are growing. And that's the big change that we realized in the last well, maybe a couple of 100 years, depending on how you look at that, is that we see that humans are starting to really leave an imprint. And it's a very a nice way to have a few of these buzzwords that I'll throw at you, but we call that the Great Acceleration. What is this diagram showing? The diagram shows at the bottom is the time, 1750s till about year 2000, and a bunch of observations that give, these are numbers about different features of our planet that have to do with us. Population dynamics, look at the population numbers. We'll look at that in a little more detail in a second. But you know that bottled forward, not trivial, but not a whole lot, and then it exploded somewhere in around the 1900s. The use of water, human use of water, exploded somewhere since the beginning of the prior century. There's no vertical axis here because they're all normalized. If there's scientists here, you are horrified because there's only a horizontal axis, not a vertical axis, but they're all on top of each other for dramatic effect, and it usually works much better that way. There are real numbers to go with it. CO2 in the atmosphere, we'll touch on that. Bottled forward, the weight, oh, this is horrible, this thing, it just keeps moving. My fingers are too big and the unit is too small, probably both of them. CO2, we'll talk a bit about that. See, all these numbers, all these curves are jumping up. Somewhere around 1900, significant change occurs. And these changes are all associated in some form with, of course, the fact that what we also saw is that population increased that. And these changes are going very fast. We don't just have change, the change is very fast. And that's why we call this behavior the Great Acceleration, reflecting the fact that things suddenly were changing at a rate they haven't changed before. And don't worry, the planet has changed a lot in its 4.5 billion years, but not at this very high rate. And that's why this word acceleration is what we put in there, right? The rate of change is what an acceleration is all about. So these curves, we'll touch on some of these things as we go by, is really telling us like, wow, things are changing quite a bit. Here's 1900. None of us can remember 1900 in this room, but you can remember the 1950s, some of you. I can remember just after that. But the bottom line is, it's all very recent time. It's our parents or our grandparents who were part of this changeover. And before that, all these 4+ billion years before that, things were puttering along pretty unperturbed and undisturbed. So keep this in mind a little bit as we explore the reason why these things are the way they are as we go about in this particular environment. So let's look a bit at people. There's many ways to look at people. The sense of the role of people on our planet. So what I decided to do is to give you a flavor of what we call population dynamics or demographics, give you a flavor of trends that are very significant when we think about how we got where we were today, but also how the future might shape up as we look farther in time. So we look at a bunch of these demographic steps to begin with. So we set the tone right, because we are the centerpiece of this Anthropocene world. All of you, and as I said, when you see text, don't worry about it. It's to remind me to make sure I say what I have to say. So don't if I don't say it, we'll move on to these things. You've all in school at some point in time learned a lot about population dynamics, and you all remember that population was growing, and it was growing ever and ever faster, and it would just never stop growing, and it would be explosive number of people. And maybe when you were in high school, like I was in the 60s, and some of you were after that, some of you were before that, you were told that this is called an exponential increase. The number of people on our planet exponentially increases. Why is that? Every couple had more than 2 kids, therefore you get more and more people. You already know this is probably not true. I'm not going to ask in the audience. I do that when I teach the students. I ask how many brothers and sisters do you have. I'm not going to ask how many kids you have. But we already saw that's what you were told in the 60s. I have 3 sisters, and I had a small family, 4 people. That is why it grew so fast. It was an exponential growth. And you heard, if you went to school in the middle part of the last century, that there'll be, I don't know, 12, 14, 15 billion people walking our planet around now. That's what you were taught. And that was called, if you had the terminology, that was called the J-curve of population dynamics. It was growing at a rate of a few percent, a couple of percent a year, which meant that the human population would be doubling in about 35 years. So if in 1960 they told us the human population would go from 5 to 10 billion around now. What we have seen, that this actually did not play out that way. The first thing we've learned in the recent window, sort of since the 90s and the year 2000s and onward, we've learned that this growth, the number of people that are added on, is still making the population larger, but the rate of that change is slower. In other words, the shape of this curve, which is called the J-curve population, is really not going on and on and on this way. It's leveling off. It's already starting to level off. We call that the S-shaped curve. Meaning that the growth rate is slowing down. And today we have about a growth rate about 1.2% a year in population around the world. And if you do that in the math, it takes about 60 years to double the population. That's not going to happen because the curve has been slowing down. It might actually be not unlikely at all that we'll have a 0% growth rate. And if we go on the way we are and if we don't pay attention, it might be a negative growth rate because we are really pretty much pressing the planet more than we probably should. But that was the first thing to take away, that we know the growth rate did not jump up the way it is. And so we need to adjust a little bit what the predictions are on people. We're growing still. How many people should you expect? And as I said, when I went to school, I was told about 12 billion by now. Well, that's not going to happen for a long time, for a while. We think, pretty good reason, because we can do this mathematically. This is not an emotional thing like, oh man, after individuals. No, we just put numbers in a machine. We know that around 9 billion people will be walking our planet around in 2150, in the middle of this century. In 2050, not the next, 2050, middle of the century. 9 billion. That's still a big number. That's more than 1.5 billion more than we have today, okay? And that's a lot of folks to begin with. And then it gets hairier as you go farther away, what the end of the century might look like, and I don't have to worry that much about that, but I think my kids have to worry about that. The number is projected to be the end of the 21st century, so about maybe on the order of 11 billion. Like anything else, all of you know, predictions are great because you don't really have to sort of prove it. It happens and it will be different. You have another reason. But it's the best we can do because we need to understand how many people are going to walk on this planet. We have to feed them. We have to give them water. So we have to have a sense of what our planet can bear. It's not a trivial number, 9 billion people, but it's not as draconian as it was predicted to be not that long ago. So that's the first thing to take away. So that's the first trend, the growth trend. The growth trend, however, has a little kicker in it, and that kicker is actually quite a thing to think about. That kicker is in this particular diagram. It's the same diagram, the same curve that I showed you before. This is the J-shaped curve that becomes an S-shaped curve. But what this now shows, and I hope you can read that, it's a little light, but I'll explain it. What this shows is that in this greenish color is the growth in what we call the developed countries. Countries like ours, Western Europe, Oceania, Japan, nations that are well developed economically. The nations, in other words, that are wealthy around the world see a relatively small increase in population. This growth to 9 and to 11 billion that I talk about will all take place in the developing nations. Not by us. The US population is stable. It only has increased by immigration, and we know what immigration can do. Same in Western Europe, and in fact it's shrinking in Western Europe because they don't have enough immigration in Europe. Immigration is good, by the way. I'm an immigrant, so I'm also here to protect immigration. It's a good thing, and so thank you for letting me come to this country. More than 35 years ago, though, so. It all is going to take place in these nations that are in this, only the colored ones in this diagram. Not change is going to take much place in the rich nations. All the growth in population will take place in nations that are today developing. So if they are stressed today or try to achieve a level of presence that we have, you can imagine what the look of that will be like in about 50 years from now when they are starting to double their numbers of people, and they are doing that in the same way. And so these nations have to think seriously about demographics as well, what it means to have large families like we did about 100 years ago, and stabilize that. So the distribution of population growth is very important. It's not going to be a big one in the Western world. It's going to be a huge one in these developing nations. There's some countries around the world that are struggling hugely. Japan is a negative population. I mean, people get older, but they don't have many young people anymore. That's another problem. It's a different talk for a different time. But it is important to realize all the change will go in the developed nations. And developed nations are called developing nations, because they are trying to develop, like following our trajectory, and that's something we want to think a bit about as we go about. So nearly all the growth will sit in those particular nations. So a number of 9 billion is meaningless if you live in the US, because we're probably going to stay around 300 so many million for a long time. Yet somewhere else they're going to grow from 20 million to 60 million or something like that. Like Nigeria in Africa will grow enormously, for example. It's one of the nations that will be one of the larger nations. And it will probably grow over 100 plus million by the end of the century, where we really don't grow very much. So that's the second demographic trend I wanted to get your attention, the distribution. There's a third trend, which is actually also very interesting. And the third trend is like the distribution around the world is one thing, but there's another distribution taking place. And that third distribution is that we are moving to cities. We are all around the world moving to cities. In the sort of about 10 years ago, 11 years ago, we had the level whereby 50% of all the people were living in cities. Today, more than 60% of people around the world are living in city areas, and those are big cities. When I was a kid, I taught you about what I learned about population. I also heard about the city called New York. I thought it was a really amazing place, and I saw pictures and stuff like that. And why was it an amazing place? Because it was called a mega city in those days. What it meant, it had 10 million plus people. And there were very few of those cities. You can see there were really Japan, Tokyo, and New York were sort of the places that had a large population. That was sort of the 60s and the 70s. What has changed is now on this map, you don't have to read the details, but you see this is a map of the world, and all these dots, all the big red dots, are the mega cities of today. We have 25 or so, what the number says on the map. We have more than 25 mega cities today. And those are stunning places. Those are amazing places to go to. Yes, Tokyo is still very large, 30 plus million, because it depends on how you spread it out. But things that used to be small, Mexico City, Sao Paulo, Rio de Janeiro, you go to places around the world where suddenly there's tens of millions of people living in cities that really don't have room for tens of millions of people. If you ever have a chance to go to South America, try to visit those emerging cities, and you'll just be astonished, but also probably horrified to see how people have to live in those places. Whereas in New York, it must be good because nobody can afford to live there, but there still is about 10 million people in the area. In Rio de Janeiro, nobody can live there, and there's more than 10 million people living about. So the third trend we're seeing is that people are concentrating, and that trend is not changing. That's actually a very rapid change. I update this slide regularly, and this number always was 20 when I sort of did it a couple of years ago. These numbers are going very quickly. And by the way, that might be a solution. If we worry about the environment that we have to deal with, the fact that we concentrate might make it easier for us to deliver some of the needs that we have. I'm not talking about healthcare alone. I'm talking about food. I'm talking about water. I'm talking about environmental impacts. Concentration might be our friend in the end. Unfortunately, for many of those cities in the developing nations, Nigeria is also highlighted here, of course, there's a lot of poverty there, and they won't see a whole lot of those benefits as we go in that particular direction. So, a lot of more people, primarily growing in developing nations, and concentrating in city areas, in ever larger city areas. So, what do you do with all these people? Well, they need to eat, they need water, and they consume energy. And that's the pressure point for human society. And the more developed a nation is, the more food it takes, the more water it consumes, and the more energy it demands. And we are the absolute leaders. We're number one, pretty much on everything. I'll show you some examples of that. But as you grow population, you have to ask these questions. Can we really deliver the food for 9 billion or more people? Do we have access to the water for 9 billion or so people? What does that mean? Well, on average in the US, you can see the numbers up here, we consume about 3,000 calories, it should be kilocalories, but we call it calories per day. That's about the consumption. That's considerable consumption. You don't need that, by the way. You need no more than 2,400, but we do on average eat more. And you wonder how that plays out. It's not very surprising how that plays out. You need 1,000 to sustain yourself. If you have less than 1,000 calories a day, you're going to eventually die from starvation. It's just not enough to keep burning. We're warm-blooded animals. We burn the food to actually keep our system going. That's how we use. That's why the calories is an energy value. We need that sort of minimum amount. So we need to make sure that we have enough food to meet this threshold of 1,000, which is the absolute base level. It should really be around 1,800 for an average base level. The good news is there is no pressure whatsoever on the amount of food available to meet that number of calories for 9 billion people. What it will tell you in a second, of course, then, why are there people that don't have food? And we'll touch on it in a little bit later. But we can do the calculation. The global food production is not a limiting factor. Meaning, if you just see how much food we can produce, how many people we have, there's enough to eat. Water, well, same story. You sort of this number, this is a basic number to think about. You need about a cubic meter of water, which is this by that. That's about a jerry can full on a year basis as an individual. That doesn't tell you anything. That's just a number of water bottles you consume, essentially. You consume about 1,000 times more water without knowing that, because agricultural practices, infrastructure uses, as we have farming of animals, that consumes enormous amounts of money. Growing coffee, all this stuff takes water. And so you actually are using this number right here, 1 million liters of water a person a year. That's a lot of water. Again, if you don't put the number on there, there is enough water around on the planet to actually give that to the population. Although this number is too big. That number we can handle. That number is awfully big. That's kind of hard with 9 billion people on our planet. And the reality then is, as you play this out, is that how we solve this is simply by knowing that some of us have a whole lot more than others. So the developing nations are using only a few % of that access to food and water than we do in the developed nations. It's not an indictment, it's just the observation of numbers. The good thing is I'm a scientist, I plot things, I have an XY diagram. There's no values added to it, you can do your own thinking as we go about. But we are, this is a good number to think about, you raise a kid here, as many of us did, we let these kids sort of, they take about 15, 20 times the resources that they would have in a developed world. Of course, our kids live at a very high level of quality life, and then we'll get to that also. But it gives you a flavor. And if you're a developed nation, you want to live like us, then you want your kid 15 to 20 times what it has right now. Remember, and that's 7 billion people that don't have it right now. They want that what we have. Now the pressure points start to grow as we go by. And as we do that, what we have to keep in mind, and that's the reason when we talk about environmental science, is that we ask the earth to deliver all these goods to us. Remember, this comes from Earth. It's our planet that is delivering all these needs that we talk about. And so as we expect more from our planet, somehow it has to deliver. There is no other planet. It's not going to get any bigger. It's the same planet, and it's been the same for a long time. So the question really is, what is the bio and geosystems of the planet going to do? Is it able to ultimately sustain this? What is the number that our planet can take? 9, 11, 13 billion? Time will tell. No worries about the 9 billion for sure. Meaning 9 billion if you distribute it all. 11, that's probably still okay. 13, that's going to press it for a number of reasons as we go about. So let's look a bit at these things in a bit of detail. Let's give a little bit of time to look at some of these items to get you a flavor. And to put it in a bit of context, there's got to be a way we should think a little bit less as a developed nation. Food. I told you that you do the calculation about food production in the world, You multiply that by 7.5 billion people that we have today, a little bit less, 7.3, but doesn't give you an approximate number. And if you do it by 9 billion people, we've been incredibly good at generating food. There is enough food in the world to feed all these mouths. Maybe as well, when you were in school, you learned there's going to be a huge problem with food. You were told too many people, not enough food. Did you hear that when you were in school? Was that what you were taught? No? Yeah, you were. I'm sure you were. Because the Green Revolution happened after us. We are smart. We saw this problem coming. So we realized, wait a second, this is not good news. If you don't have enough food for 5 billion people, then how's it going to be when we have 7 or 9 or 11? So we actually, in the 60s and 70s, developed better ways to grow crops very efficiently, called the Green Revolution. We're clever. When the need is there, we do something very smart. And today, we're so clever that we really have enough food to feed 9 billion people. Yet, unfortunately, there is hunger around the world. And the only reason for that hunger is politics. It's just pure politics. Economics and politics, lump them together. There is enough food. People don't get it because either they don't have it locally, so it has to be imported, which is fair enough, and it's held back as a weaponized way of working with your people. Holding back food, basically keep them quiet. The fact that 900 million people on our planet today are hungry where it's unnecessary is kind of ludicrous because there is enough food, it just doesn't reach them. It doesn't reach them because you and I don't want it. It's simply because the infrastructure is holding it back for reasons that are, some of them are actually pretty ugly reasons to think about. It's a way to repress your people as you go about. 250 million kids are hungry. It's kind of ludicrous. It's completely unnecessary. Yet, it's the reality of our planet. We're very smart. We're also not a very nice species. Okay, we have a few edges in as the system goes by. And so the developing countries, the less developed nations, where the population growth will take place, are the most stressed ones. They have the least access to food. Now, they also don't grow it as much as we can because they live in parts where you can't grow it very well. But that's what exports and imports are all about, of course. That's how we get our stuff. We never used to have a lot of things either and have everything at our fingertips. And the real issue is you have to understand that this balance of scarcity in some places is artificial, that it's a matter of how you get stuff, the supply that goes with it. And more than anything else, it is also that much of the food that where it is abundant is just wasted. It's really not used for what it was for. I'm talking about basically generating way too much food, but also generating foods that are really very intense to generate. I'm not a vegetarian, but I do know that because I eat meat, I consume a lot more food in the calculation of calories than I would be if I was a vegetarian. I'm not going to convince you to become a vegetarian, but it's reality that you do the calculation to figure out we're wasting a lot of that energy in food, not only by eating meat products, but also by simply throwing it away. We have a nation where the numbers are 40% or so of the food is chucked out because it's left over in processing, in not being consumed and the like, and it's just hard to get it away. And yet 900 million people are hungry. Not a good thing. It's nothing to be proud of, that's for sure. Water. Well, water is a little trickier because water is really hard to get around. Water is very unevenly distributed around the world. This is a crazy map. Sometimes I make these maps that are a little bit different. This is a map that actually shows the nation that you recognize. Here's South America, North America, Africa, here's Asia, here's Europe. But now it's inflated by how much water they have relative to these other ones. What do you see as a picture of that? Well, South America, that's water country. They have lots of water. That country is not stressed for water. But here's Africa, the country where we see very large growth. There's not a lot of water in Africa, and there's not going to be a lot of water in Africa. And so now we see the place where population growth is going to increase significantly, very large, is also the one that's most stressed. Water is very unevenly distributed. But even in our own country, we know this. Let's say the unpleasantries between Florida and its northern states, California and its neighboring states, are just examples of the fact that water we consume in large amounts, and we know we don't have it. You are in Michigan. We are the Saudi Arabia of the world. We have nearly all the fresh water there is. If you want to just show how wealthy you are, you go down, get a bucket of water and say, look, this is what we scoop out of the ground. That's what the Saudis would used to do, right? They have oil, a bucket of oil to show how rich they were. We have water. And by the way, you go to the store, I drove by these gas stations, a gallon of gas was $2.30 or so, $2.40. A gallon of water in the store is $3.50 or something like that. So, I mean, oil is cheaper than water. We have lots of water. This is the wealthiest thing we have, and eventually somebody is going to start to think about capitalizing on that. The problem is it is difficult to transport. A bucket of water is quite heavy. If you move water to Africa, that's a long way to ship water. You can't really move it around in that same way. So while there is lots of water in the planet, it is very hard to move around. And the consequence is simply there are droughts, significant droughts. Even we will go through droughts, but it's droughts because of climate, not because of absence of water in the sense of the long run. But pretty good. We live in Michigan. We are the wealthiest people when it comes to our resources, water. So next time you see Lake Michigan, you think, well, there's a lot of water there. Yeah, that's a quarter of the fresh water of the world that we have access to. And next time you go to California, you don't bring presents, you bring a bucket of water, right? That's essentially what they want. Just bring a gallon, you never know, can water the lawn as we go about. So that's a huge problem. We can't solve that readily. There's enough water to have for 9 billion people, but it's so unevenly distributed and hard to move around, unlike food, which is easier to ship. So that's a big issue that we have to deal with as we go about. And then there's the third piece, and we call this group of topics the food, water, energy nexus, because it sounds really good, nexus, it sounds like a connection and stuff like that, but they are deeply coupled because food and water and the third leg, energy, are really connected in that you don't have energy without consuming water, you don't have food without water, and you don't produce food without energy. So we collect them together in this food, water, energy nexus, and that brings us to this point about our energy future. And this is where we're standing apart really from the rest of the world, and we being the developed nations. Again, a lot of graphs. I don't have to worry about any of the numbers on the graphs, just to realize that what this simply shows is the fact that we need more and more energy as we get from the 1990s to about this is 2035. This is the prediction of the energy that we need as we go about. And it's not easy to see from where you are, but the Western world still has an increase in energy, not as much. Most of the energy increase will, no surprise, happen in the developing nations because they are developing. They too want hospitals. They too want roads. They too want transportation. They too want stores. And so that's where the energy growth will take place. And so we know that the demand for energy is going to double from today in 35 years. So by the year 2050 comes around, we need double the energy to power our planet. Not so much to power the US, because we've done pretty well, we've leveled off quite a bit, but that remaining group of people, which is a lot of people, they will need that energy. That's where the growth is. And they want that energy. And energy is something that you can't do without. The quality of life is linked to energy. So, what does the energy future look like? Well, we in the US, it's very interesting, of course, we are now energy independent. We suddenly decided to do that because we could. We always knew, by the way, there was enough oil and gas in the US. It's just simply that we were told we had to import it, but we did because it was cheaper to import it. We were told. Not really, because you have to supply an entire military to make that happen, but it was cheap to import it. But we had lots of gas and oil. We always knew that. It's never been an issue. But there are other parts in the world need that energy. The bad news is there is no indication that we're changing the way we are getting our energy. Even though, and I hope some of you are thinking about that or have done that, we have some solar panels and we have a few wind farms in Michigan. The reality is there is not a plan anywhere that would change significantly where we get our energy from. Nuclear is on the way out, mainly because of, it's an obvious worry for people. You might actually wonder why it's such a worry given other things, but it's a worry. Alternative energy sources, water, sun and wind. Well, there will be a supplier, but it really is more of a boutique supplier. 80% of the energy in the next 35 to 40 years will still be from fossil fuels. Why? Because it is easy to get the energy out that way. It's easy to transport. The infrastructure is there. And so what we're seeing is all these countries that need more energy will simply will get it from fossil fuels. And that has a bit of a clincher that we'll get to as the next topic. But it's remember to keep in mind that energy demand will be there. There will be double the need for energy in the next 35 to 40 years because developing nations want to develop. And they may not reach our level of development, but even if they stay way below, they need a lot more energy because they don't use much now. And it still goes primarily to fossil fuels. As much as you hear and as much as happy articles appear in the New York Times and USA Today or whatever your favorite newspaper is, talk about some less favorite ones, but they all mention fossil fuels, alternative fuels, but it really is not a big player still. Why? don't really know, except that you could imagine it probably has to do something like, well, if there's going to be winners and losers, the winners are a pretty powerful bunch so far. They don't like to lose, and so getting out of this business of fossil fuels is not really very attractive for most of the industry that we have. And even this talk about coal in Kentucky and in Utah sets that tone a little bit. It's kind of a ludicrous discussion if you know something about the geology, about energy, about talking about coal. But we do because there's powerful industries there. For those third world countries, they just don't have the money to actually build that alternative energy infrastructure. It's easier just to get the oil. Nigeria has lots of oil. South America has lots of oil. So this is one of the other trends that it goes. And why is this a concern? Is that now we're starting to realize how we're tinkering with our environment. What we're doing, let's skip this one. What we're doing is, of course, that we realize that as you burn fossil fuels, and rest assured, this is not a climate change lecture for 50 minutes. I'm a pragmatist, but I want you to understand the implication. If you burn fossil fuels, you simply are changing the atmospheric conditions. Remember, we live on a perfect planet, just right for us, and the reason is because there is CO2 in the atmosphere and there is methane in the atmosphere. That is great. Without that, you and I would not have evolved. What we're doing today, we just get a little bit more of the good stuff in there. We say, let's put a little bit more CO2 in there. And the planet simply reacts as it has done before. It just warms up a little bit. This is not an emotional topic or a debate about science. It's just the way it goes. These greenhouse gases that are being produced by fossil fuels do the same thing that they did when they were produced earlier on by volcanoes in the early Earth. They simply warm the planet a little bit. Today, we are burning a lot of fossil fuels. We're releasing the CO2 in the atmosphere. That simply turns up the thermostat. You go to the room where there's no one on here, it's all electric now, but you walk up, you turn up the thermostat. When I do this for my students in class, I do this and they look at me, what's the guy doing with his fingers? You and I know, right? We turn up the thermostat, you turn something. Now, of course, you stand like that. And my age group stands like that because I have bifocals, right? But that's simply what's going to happen. The reality is that what we're seeing is just playing out the fact that we are changing slightly the atmospheric condition, but that slightly makes a big difference for us because we are so sensitive to this about 12, 13, 14 Celsius temperature of average on our planet. This is not a debate who's to blame. This is just physics. More CO2, more methane, gets a little warmer. And indeed, we've been pumping away for a century, and the last decade was the hottest one on record, and this current decade is probably going to beat it, although it was a little cold today. It was crazy warm just a weekend ago or so, you know, and it sort of was kind of a bad winter. We don't talk about weather, we're talking about average temperatures around the planet. As we consume more energy, we will simply see the fact that the planet will respond, as it has before. CO2, methane, greenhouse gases warm the planet. That's what we want to worry about because we really are not particularly good at handling that. We see all these things, as I said, don't want to make it a climate talk. Now, about 20 years, 30 years later, we're starting to have good measurements. We can track all these things. If you go on vacation and you like cold vacations, although I'm from Michigan, who would go to a cold place, but you might want to visit a cold place just for fun, and you look at glaciers, Glacier Park will be called in the future just Park, because the glaciers are gone, so Glacier Park will be just Park. Park your car, perhaps. No more glaciers. Glaciers are retreating. That, by the way, is a bit dramatic because glaciers are not a lot of ice, and they quickly retreat like an ice cube on your countertop in your kitchen. It's quickly gone. If you put an entire tray of ice on there, it takes a little longer. Nonetheless, ice is a great indicator. What we mostly look at is how much snow cover there is, how much the snow cover we can see. It's going down because it's a little warmer. We've had that in the past, by the way. The Earth has been a lot warmer with much less ice. It's just that you and I like the way it is today. And so as you change it, it's changing not for us in a good way. For the planet, it doesn't really matter. The planet has been ice-free. The planet has been 100% frozen in its history. The planet is just fine. You and I are not very comfortable that way. So keep that in mind. As you tweak that thermostat, it's tweaking something you may not like. The planet is perfectly fine. There's never an issue about worrying about planet Earth. And I'm a scientist, so that's convenient. I don't have to worry about our planet at least. And so this greenhouse gas increase, which is that one of these jumps that I showed you, is this dramatic changeover that we see, this acceleration. Why? Because we went from less than 1 billion people at the beginning of the 19th and the 20th century to 6 billion people at the turn of the last century, now 7.5 billion people. They need energy. They produce CO2. right? It's fossil fuels because it's oil, and you burn oil, you get water and CO2 as a byproduct, and the energy is what we consume. The water is fine, the water vapor is fine in the atmosphere. It's a greenhouse gas. Always the question, isn't water a problem? Yes, but there's also rain. And so if you have more water, you have more rain, and the atmosphere balances that. We don't have CO2 rain. It's raining CO2, by the way, on Venus, but there's no plans to go to Venus. But that's an example. We know it can happen in different places. So we know what the planet will do. So what you want to think about is like this concept of, as you change it, how it impacts us. And what we are debating is probably the wrong thing about this. Is like, well, who's to blame? You should think about what the implications are. The implications touches anything. They touch on our agricultural practices where we grow food. It will be even harder and drier in some places. It will be wetter here. Again, Michigan, can't predict everything very well. It'll probably be a little warmer. That's good. A little wetter. That's actually good too. We already have all the water in the world as well. Keep your house in Michigan, that's what I say. Or buy another one, because it's the best investment for your kids. This is the best real estate you'll have. Not yet. It'll come. Sea level rise might take place. Maybe even becomes beachfront, right? If you wait long enough, your house in Michigan might be moving a little bit. We always make this joke. I'm Dutch, as you probably heard from the accent, if not from the name. They always ask, why are the Dutch so tall? My wife is as tall as I am. My kids are 6, 7. I always say the Dutch anticipating sea level rise because they know they can't stop it, so they grow taller, so they were the last to drown. That's the idea. The Netherlands is essentially underwater. By the middle of the century, they have to do a lot of work to keep the water out, and that's not going to be a good thing for that place. But the impacts are huge on the geosystems, coastal areas, tourism, even health. As you'll know and hear about more and more, and newspapers are finally catching on. A lot of diseases that were tropic-based diseases make their way into the US. Because it's warmer. Mosquitoes don't care where they live. It's not that they say, well, I have to cross the border now. I'm not going to do that because there's a big wall. No, they're just going to fly over the wall and just move into North America because it's warmer. So health is a big change. And so the impacts is really what we need to think about. This whole discussion about climate, it went completely the wrong way as a finger-pointing exercise. Do you really care who's to blame while you're coughing away or your house is underwater? You are worrying about what the impacts are. And so the only equation we're going to give you is this equation. It's called the impact equation. Easy math. There's a lot behind that math. But we basically can calculate out what are the impacts of changes. What are the effects of change we have to deal with. And the equation is right up here. It's called the PAT equation. The impact is to do with the population. The greater the population, the greater the impact, right? The affluence, meaning how much really are we consuming, what we need, what our demands are, food, water, our lifestyle. The more of that, the more impact it will have on the environment. And the technologies, how we get our stuff, we burn fossil fuels, they have impacts. What we see is that most of these things are positives. Population is growing, the affluence, meaning developing nations become developed, is growing. And so that number of impact will get bigger and bigger and bigger. We will see more and more impact of change, sheerly by looking at the numbers of that change. The nice thing here is technology. It's possible to treat technology as a negative, meaning lowering the impact. If you keep burning fossil fuels, we made no progress. But if you, for example, go to alternative energy sources, then this number will become smaller, and we might actually lower the impact. And we can do this for a lot of different situations. And why you want to do this is you want to figure out, can you handle the change? And I'm not entirely kidding when I said, sea level rise, maybe new coastal front. Manhattan is not much above sea level. Neither is the Netherlands, but Manhattan isn't much either. That will flood eventually. If you have a sea level rise of about 3 feet, then it's hard to keep the water out. Anybody from Miami would know that Miami has invested heavily in pumps. That's today. They're pumping today to keep the water out. And there's hardly any sea level rise. Wait till tomorrow, and tomorrow is 35 or 40 years from now when sea level will go up a little bit. It doesn't take much. A few inches, it's bad. All of you had a flood in your basement. An inch of water really sucks. I had an inch of water in my basement. A little bit of water change has a big effect. Not only on the fact that the water level is higher, but also storms will be different. There's a climatic impact. There's a weather impact. All these things go with it. So how much can you handle this? How much are we ready for this? We really are just talking about that we don't like what's happening, but are we really adjusting? You go to Florida, you look at the hotels, go there while you can, because they'll be underwater soon. Maybe our president would actually remember that too, and then we'll maybe have a change there. The industry associated with tourism is going to be one of the first and hardest hit, because I go to the beach on vacation. I mean, and real beach, I mean, with salty water and not the freshwater ones. It directly relates the impact. What's the quality of your life? You need that food. You need that water, right? And you is not just us in the Western world, but also in developing nations. This impact equation helps you to understand what is the quality of human existence going to look like. How are you going to handle the pressures on water and energy around the planet? And by the way, when humans need something they don't have, they have an odd tendency to fight over it. All the big wars that we talk about were started over energy. Even though you hear other stories, they're all started because some country wanted somebody else's energy source, and they went to get it, and that's going to happen again. The difference, however, might be that water might be the new water war. It might be that water might be the reason to go to war to each other. India and China, a lot of us look at that with great horror because India is growing significantly, the largest population in a decade or so of the world. China is very developed, doesn't have much water. They both fight with the same amount of water. That's not going to play out well. Somebody's going to take over because they simply want the water. Hey, we do it in America as well, right? We dam the river, so the guys down the river have no water. Whole nations are thinking about that. So human existence, human quality, water will be a player. The other thing that I put up there, although I won't spend a lot of time on that, is that things are still happening as well in society. We still have natural processes that take place that overlay this. California earthquakes, volcanoes in the northern part of the US, but all around Indonesia region, floods when we have significant rains in Southeast Asia, which are associated with landslides, and that's sort of, it's a huge impacting scenario. Sea level change, which has storm effects. If you think Katrina was bad, just wait 20 years and you'll see the storm like Katrina happens every year somewhere along the eastboard. I mean, that's essentially what's going to play out that way. We can do some engineering against it, but it will go in that way. The thing that is often not mentioned enough, but it's something you're starting to realize more, especially the schools of public health are dealing with this now, is that diseases will also change. We are not very resilient to diseases as humans, all right? We are very sensitive to diseases. And some bugs are just not going well. You go on vacation to Mexico and you drank that water you shouldn't have, you know what I mean, right? Or that cocktail that you later on found out they used water that they didn't tell you. The next day you thought that was not a good plan. We're very sensitive to disease, and so we don't know what the impact of that is. But these diseases will become more prevalent because these critters like the conditions change, and they move to areas where we're not resilient to those particular changes as we go about. And if that wasn't enough to think about, we also have a bit of a stewardship responsibility. We are the top dog on our planet. We do what we want, at least relative to all the other species, relative to each other we don't, but we can do what we want, nobody's stopping us. We have more responsibility too because we are consuming the biological world in this process. And so what we even haven't talked about is our responsibility not to ourselves, but to all the other things on our planet. That is, the resources of the planet. You all have your cell phone, and thank you for turning it off, or nobody got cold tonight. But that lithium in your cell phone does not grow in lithium trees. That's mined in Chile in a very horrific way. If you ever have a chance to go to lithium mines, you'll never start your cell phone again. Resources be taken out of the earth in ever greater amount. But also biodiversity. The pressure on life, on animals and other species, is just growing because we are consuming not just those animals, we're consuming their habitats, their territories. And so there's a lot of things that go in this impact equation to think about. So have I depressed you enough? Then I'll turn to something else. Because now the job is to say, my job as a scientist is to tell you a little bit what we know about these things. And scientists are not usually very good at saying what they know because we all say, yeah, maybe this and that. I told you things that in about 10, 20 years ago we wouldn't talk about. We wouldn't give predictions about climate. We wouldn't give predictions about energy because we know that prediction is just a prediction. It's like your stockbroker saying, invest in that fund. I guarantee it's going to double. And 2 years later, well, I guaranteed it, but it didn't play out that way. Right? As scientists, we were worried about that. But we all should take more responsibility. What are the solutions? Now this is where you come into play. Once you understand the rules of the game, then you can figure out how to play the game, what the solutions are. And there are solutions. This is not at all a depressing, like, well, we're doomed. Not at all. We might be having to change a little bit, but there are solutions. The obvious things we've done, we're very clever. We made the pie bigger. When there was hunger predicted in the 60s, we had the Green Revolution. There was food for everybody. Within a decade, we did that. Crazy. Even before that, when we were eaten up by big animals, we figured out fire keeps them away. So we're very clever. So making a bigger pie is a metaphor for understanding that we can actually maybe make the resource that we need go a little farther or be more creative about it. And we've done that every time. So I always tell people, we're not passive players. We'll find a way. Now, that will come at a price to some and not at others, but we've always found a way, right? You wanted to drive from Boston to California. It was a long walk, so you actually invented the car, and now we drive, right? We are very clever. And the driving was too slow. Well, maybe we can fly, and we invented planes, all right? And the food was scarce, and it goes on and on. We're very good at that. There is the other topic to talk about, and it really is a very sensitive and delicate topic, is of course that I keep the food metaphor because it usually keeps people ready to go, you know, and I have a class from 11 to 12 with students, and so the more I talk about food, the less they listen. That's kind of the end. That's on the exam, right? But there are too many of us probably. That's a harsh thing to say because I can't imagine not having my kids, and I'm sure you have the same, and everybody thinks the same way, but there are probably a lot of us. Since we have no predators, we will keep growing and growing and growing. So putting fewer forks on the table is really something to consider, and we've done that in the Western world, right? As I said, I'm one of 4. My mom and dad were of 10, and I don't think that their parents were of 100, but I mean, large families. Within a generation that skipped. Most of my friends, who are now also, according to my students, old people. I'm an old people person. I'm an old person. 2 kids, sort of typical, maybe 3. You're actually seeing a change in the younger generation around in the Western world. They go back to 3 kids on average. That's in part because with 2 you don't keep up the population and you have actually more old people than young people. You get what we call the Japanese problem, or the Italian problem is the inverted pyramid. Too many old people, too few young people, and the young people have to carry the needs of the old people. Not good news. And so you see slightly larger growth, but we've done that in one cycle. How we did that? Well, family planning, right? That was just what it is. It's a euphemism for things that you know what it means. And so we need to talk about family planning in the developing nations. We just have to bring it to the table. And that's a delicate topic, not because we are telling them what to do, but because of the dynamics of the developing nations. The guys there are still the old-fashioned guys. 5 kids is the minimum. 10 kids, that shows you're a guy. The women are the ones to talk with, but you have to be careful because you might educate the women there about family planning, but the guys have to be educated as well. And that was a mistake that was made in sort of the beginning of this century where a lot of women education was taking place. They forgot to also tell the guys that it's okay to have fewer kids. And it sounds very trivial what I'm saying, but it led to a lot of violence in families and a lot of problems in some of the programs in developing nations by not realizing it's a family issue. It's not woman planning or children planning, it's family planning as you go about. And then, of course, the last thing, which we all know we try to do to our kids, maybe we just have bad manners. Maybe we're just too greedy. Maybe we should wait before we eat, before everybody else has something at the table. We are right now, and that's really where we are sort of bad-mannered people. We just get what we want and we take it. That is the other thing that we need to realize, that manners may come into this. There may be some environmental justice necessary or environmental equity, realizing that maybe we want it, but maybe we should not just want it. Your kids might be hungry. You told them to wait till everybody sat at the table, and you wait even though they were hungry. Wait till we start eating. So the manners is the other metaphor to think about, that we have to realize that we're not alone. We have to deal with that as we go as a general group. So making more, having fewer people, and being a little bit more equitable as we go about. So the last slide, and I have 2 more minutes, and the word's on there, but I just want to give you a sense of why things are not moving the way they do. We know what to do, but why don't we do that? And that's entirely a sociological feature. We as humans are not wired to appreciate slow change. You probably, all of us, or most of in the room, a few younger ones, but are a little older, we don't think of ourselves as that much older. It went so slow that we remember pretty well that we really were 30 or 40. I don't remember when I was 10 years old. That's too far away. But I still think, until I look in the mirror, that I'm sort of in my 30s. And I know I'm not. I'm actually 32 right now. We don't appreciate slow change very well. And all the things that I talked about are slow change. Even though they're accelerating, they're still relatively slow. We don't react to slow change well. But man, you give us a disaster, we jump up. So a disaster might happen, but there are no disasters. There's not going to be suddenly water falling from the sky and there's oceans all around us suddenly. Slow change is our biggest enemy. We don't really appreciate it very well. That's why you have to understand what is coming and say what 20 years down the road will look like. The other thing we don't like is change in general. I don't know how many of you live in the same house that you've lived for the last 20 or 30 years, and you probably saw better ones, but you thought, I like it. It's a good place. I dump my car every few years because why not? But you know, we just like what we have. We're not good at changing. We're also not really good at allowing change because it costs money, right? So we basically not want to invest in the future as we go about. It really is possible for us to adjust to all these things, but it will come at a price. And it's always come at a price. Unfortunately, many of the times we paid prices for change was in responses to wars. When there was a major war, Europe was rebuilt after the Second World War, not because Europe said, well, let's have a war so we can rebuild. No, it just happened to be a big change, a dramatic effect. We all rallied, and suddenly you can build a whole new world to go about. I hope we find a better way than a war to make our next change. But it's not impossible that that's basically how it will go because of our need for water. So it's easy to talk about these things from a distance. But I won't play the slide. I'll have a last clip to show you in the end. But it is important to realize that individuals can make differences. And so I'm not going to tell you to become a vegetarian and have lower food intake, but what if once a week you don't eat meat? 7 of you in the first row will make 1 week vegetarian, an entire vegetarian, right? So we can make individual changes. You can run the water a little bit less. And it all sounds so trivial, but multiplied it by 7.5 billion, okay? So if you turn the faucet off 5 minutes earlier times 7.5 billion minutes, that's a lot of minutes. And so the fact that we usually shove this away from us and say, well, as a community we have to do, our politicians have to do that, rest assured, they're not going to do anything. Governments are not made for change. They're made to do for the status quo. They have too much invested. But you can make change. You buy a better bulb than the ones we have here, and the like as you go about. So what I want to, as the message in the end, is that we talked about the Anthropocene, is where we live in the future before us. But of course there's a future for us in there, because we're very clever. We find our way. We have always found our way. But we have to realize that we found our way by understanding the things that are before us, the changes before us. Things are happening, things are changing, and we have to respond to that. You can't just sit on the sideline and just let it happen, because it will actually play out in not a very pleasant way. But we've always adjusted to that. So this is not an all negative talk. Climate warming, yeah, it changes the planet. We'll adjust. Everybody will move to Michigan. So from Florida back to Michigan, right? Yeah, that's going to be the new thing. Arizona, it's out. Move to Michigan, right? So keep that house. We'll find ways. And same with the rest of the world. We can feed the rest of the world as we go about. So yes, there's of course a future. Now the question is what that future look like. That's a choice that you'll have to make. So what I thought I'll do as the last minute, because it's kind of cool, is to give you a bit of a flavor of what life has looked like as we go about. I hope that works. Let me see. This is about us. Early Earth. Not very habitable at the time. Liquid water. Multicellular organisms. More complicated organisms with cells, with nuclei. And even more complicated. And then moving to land, from the ocean to the land, a big change. Here we are, our ancestor, mammals. This is your family. And we became clever, we used technology. fire, build cities, unfortunately fight wars. That's a pretty perfect planet that we live on, though, still. Pretty nice. All right, thank you, and I'll answer questions if you have some. Fracking, okay, so that's a question about that we now call Oklahoma Earthquake Alley as opposed to Tornado Alley. Scientists have joked that nobody thinks are funny. So, you know, Tornado Alley, Oklahoma. So we call it Earthquake Alley now. There's more earthquakes in Oklahoma than there are in California. And that's because in Oklahoma that they inject water. This is not yet fracking. So if you inject water in the subsurface, you basically are producing, you're loosening the stress state so you can actually get some earthquakes. So fracking, which is the intentionally generating fractures, because that's how the gas is released, does the same thing. It generates small earthquakes, but they're very small. They're controlled because you don't want it to be big, because they want to actually just open them up a little bit. And so, yes, so one of the things that we've decided to do is to become energy independent. Why are we energy independent? It's because we decided to get the gas out that was always there. It was never news we don't tell the politicians what we knew as scientists, because my God, imagine they'd play this out. But we always thought there was gas there. It's just hard to get out. Well, Shell and Exxon know how to get it out, oil companies. They crack the ground and the gas comes out. This is why we're energy independent. This is why our gas price, by the way, is a third of what it used to be, because we have way too much gas now. We're exporting gas. We are an exporter of energy. The US is an exporter of energy. 10 years ago, we thought we were on our knees begging for fuel, and now we export it. Don't tell anybody else. There's more oil in the Rockies than there is in Saudi Arabia. We know this for a long time. It's not pleasant to get it out. It's even worse than fracking, but it's there. The Canadians have it. They do. If you ever go to Canada, to Alberta, they basically get the oil out and they sell it to us because we are happy to buy it from them. There's a lot of resources on our planet. The fracking is just turned out to be clever because the drilling got easier. The Oklahoma story, by the way, is not about getting gas. It's about that they pump water. They have to get rid of water, which is a sloppy way of doing business. But yes, well, we don't want more earthquakes. That's not good. But yeah, the fracking part. But the story here is we were clever. Again, we needed more energy. Okay, well, there it is. On the Michigan, there is actually gas. Companies have looked at that. Michigan doesn't have fracking, decided not to do it. Why? Because there are very good people in government in Michigan. Oh, wait, maybe it's because it's $7 only a cubic meter. There's no money to be made in gas, and so they're not going to frack in Michigan until the price go up. But there is gas here. In fact, here, underneath you here, Antrim Shell. And they have looked at that every now and maybe some of you have seen a drill rig that went to your neighborhood, that they looked around and they said it was dry, and it was because it was just not worth the money. But there's lots of gas. So fracking generates small earthquakes, but that's the whole point. That's how the gas comes out. Made us energy independent in 10 years, by the way. I mean, it's now 10 years, but we've been independent for quite a while already. Clever. We have all the water, we have all the energy. We're actually doing pretty well. That's why we're a developed nation, by the way. We're pretty clever. Florida underwater. Well, so that's the other side of this whole debate. As we are changing the atmospheric conditions, what we're doing is we're essentially warming the atmosphere. And the quickest reaction in the atmosphere is the fact that as you warm the atmosphere, ice and water will react. Now, you may not appreciate this, but you always hear about ice melting and that sort of... the biggest contributor to the increase in sea level is not the melting of the ice, it's the fact that the ocean got a little warmer. Warm water is slightly bigger. How much difference can that make? Not a lot. But 10 centimeters is a lot of sea level rise, and that's what the oceans do. Now, the melting of the ice caps is not good news either. I mean, the accelerated melting that's taking place will contribute to more sea level rise. How much? That's when we decide to stop turning up the knob. But here's the bad news, and I promised myself I wouldn't give you bad news. If you go to a room and it's cold in the room and you want a little warmer, you turn up the thermostat, right? And immediately the room is warmer, right? Is it? Is the room immediately warmer when you turn up the thermostat? No. CO2, greenhouse gases, is the thermostat of the Earth. We have turned up the thermostat, but that room needs a little while, the planet, to actually adjust to that new setting. We'll see increase in warming even if you stop today burning any fossil fuels. That is the bad news. So yes, Florida will see significant sea level rise in the next century. Probably 3 feet or so, maybe more, depending if you burn with fossil fuels. And unless we change the atmosphere in a negative way, that will happen for a century. That's why the Dutch are hosed. I mean, they are underwater, half of them. It's just, you can't stop the water unless you keep pumping it out. So sea level rise is probably, and I've always sort of, as a geologist and being Dutch, I always use sea level, of course, but it has always been the poster child that we should spend more time on. Instead, people focused on climate as a weather pattern. That's complete nonsense. It's hard to understand climate change from weather. Everybody had a cold winter and a warm winter. And everybody had a snowball in April, and then they had sort of like sweating in January. Weather is not climate. Sea level rise, that was the marker point. But it's so slow, so little bit, that only people that were living close to the sea would actually notice the difference. And who do you think were the first ones that raised the alarm about sea level rise? You may be surprised. So who do you think raised the alarm in the US? Scientists? Yeah, maybe. You know, the military. Your tax dollars today are being spent, billions and billions of your tax dollars, to relocate all the coastal installations. The military has seen this for 30 years. They know this was coming. Of course, they're not allowed to say it out loud because climate change is not true, it's a hoax. Nonetheless, we're going to move all the harbors anyhow, but it's a hoax. No, the military is spending billions of dollars today to move all the coastal installations because they know the sea level is coming. And you know, you have this much water change if you are a coastal area, and if you have a boat, you know, that's not good. That's actually a lot of water change. And so, listen to the military. They got it right from day one. They just didn't talk about it because it was not a good topic to talk about. But today, much of your tax dollars that are being put into the military are not just to buy absurd planes, but it's just to relocate the Navy, because that's all the water level is rising. The military for you. Go ahead.
On one of your slides, there was a spiral, and you were talking about the billions of years. There were two words sort of towards the bottom left side. One was era, and the other was period. Would you explain the difference between them?
Yeah. Well, like anybody else, scientists love terminology. And so we break down the geologic record into different groupings, into different time windows. And what matters is that some of the larger breakdowns reflect primarily what kind of life dominated our planet. And the big breakdowns were when we had a certain group of species or a certain form of life that was dominating, that died out because of some extinction event, and then another group came up, and that's how we divided up. And we use these terms era, erathem, period, and all these terminologies are different scales of that subdivision because you keep breaking it down. It's all based in the last 500 million years on life. Before that, it's just based because now we can actually take a rock and put it in this fancy machine and get the number out of that. But in the old days, we only had life to actually judge that with. And so that terminology reflects events in life. And I didn't talk about extinctions, but extinctions is big events in life history. The dinosaurs got extinct. Everybody knows that. That's an example of a change from the Mesozoic to the Cenozoic periods. So these are terms that describe significant changes in life. So the Anthropocene, here's the irony. The Anthropocene that we talked about is used, of course, as the human era. Sometimes I'm going to have a dark mood. I say it's the end of the human era because we're not going to survive this way if you keep going this way, because 1 million years is a lot of years for us. We've only been on this planet. The way we live, few million years, and depends on how far you want to go back. Modern humans, what is modern, but a few thousand years. To say that we're going to live another 2 or 3 million years is not very likely. Probably something else will happen as it goes about. But geologists break it up in life. That's how we started that. But also life told us something about the environment. Right? So we saw that animals were starting to move from the ocean to land. Well, why did they do that? Well, because there was always opportunity. It's essentially real estate agents were selling land. Well, why live on land? Because the ocean was so much competition. If you could live on land, there's nobody to compete for you. So all these animals tried to get out and live on land. They could live on land because the atmosphere had changed. It allowed them not to get burned by solar radiation. You and I wear sunglasses because we don't do well with the sun. Imagine if we lose the ozone layer, you would not be able to see after a few years. You would have cataracts and you actually go blind. Animals crawled on the land because we built this layer, the ozone protective layer out there. Life is pretty much how geologists have grouped it. That's also why we talk about the Anthropocene, because life is us, and we are a driver of the change of our planet. Lots of terminology, and it roots around life. Life in the last 500 million years. I mean, before that, life is very simple. We didn't group it that much. I know 500 million sounds like a lot, but the planet is 4.5 billion years old. The lady in the back was first.
Okay. You talked about the Earth having, no ice at one time and lots of ice at one time. Have we done any thought about, and you said the ice caps are melting, but it's mostly the warm water expanding that's creating the sea level rise, but also the ice caps melting. Have we talked about how much more the ice caps can melt before it becomes like very hard for humans, assuming we don't do anything really clever or anything?
It's a very good question. So the question is how much, what do we know about the sea level rise from the melting part? We know we can do the exact calculation. If all the ice of Greenland melts, sea level would rise 7 meters. So that's 20 plus feet. All the ice on Greenland melts. If all the ice on Antarctica would melt, this is the South Pole, right? Not the Arctic ice, but the South Pole ice, the sea level rise would be about 75 meters. So multiply by 3 on metric, so do your number, 200 something feet. So we can do that calculation because the volume of ice simply was added to the ocean water in the expansion. That's a very large rise. Now, we've had times where nearly all the ice was gone and the planet did just fine. We didn't live on that planet, other critters did. There was a time when nearly the Earth was all ice. We had ice ages as well. When the ice ages were here, sea level was nearly 100 meters lower. How is that? Well, we increase sea level today by melting the ice. If you grow ice, you have less water. And so we actually had lower oceans for a while. And by the way, this is a crazy plan that somebody calculated out. We can actually fight sea level rise by freezing the water back on the poles. It'd be very expensive. It's probably not going to play out. But we actually had times. And by the way, that was important for us because the reason why you and I are here in North America is because sea level was about 100 meters less about 16,000 years ago. You could walk from Asia to Alaska into North America. So Sarah Palin was right. She could see Russia and walk over there. But it was, so it is up and down. So and for the Earth, it's completely not an issue. It's a non-issue. It happened all the time. We've had the time when there was really hardly any ice. We call it the hot house window. A lot of plants. That's good because those plants gave us oil down the road. It's the oil we capitalize on today. It's just that you and I are tuned to the condition in which we evolved in the last couple of million years, right? And your body does not do well with different conditions. We are just warm-blooded, and warm-blooded animals are very delicate in what they can handle in their condition. But yeah, the planet's gone up and down. It's kind of remarkable, actually. So the planet is not in danger. Do not worry about Earth. As I always say, worry about us, but Earth is just fine. But it's not going to all melt. It's not likely that Antarctica is all going to melt because that's a lot of melt. You need more than we can produce in CO2 for a while. Greenland will melt, but not entirely either, but it will melt significantly. But by the way, 7 meters is a killer, though. If you have 20 feet sea level rise, Western world is gone. You and I live on the coast, even though Michigan is not. We live at about 250 feet up, or something like that. But nearly all our wealth sits in coastal areas. You have to relocate everything. So what people point out, the economists point out, is that the sea level rise, yeah, it's inconvenience. The money is staggering. First you have to move the hotels, then you have to move the entire cities. You have to move 15 million New Yorkers somewhere else. Not to Michigan, that's not the plan. But it's going to be economically a disaster because we live on the coast. But the military is spending our tax dollars doing it today. I think so. You want to hold on to that land. So I said, that's exactly, yes, higher land, that's where people will go. But remember, we might build houses on stilts. We're pretty clever, right? I mean, not everyone wants to live in Michigan, maybe that's the answer. But we're pretty clever. Nonetheless, it's going to be a very expensive enterprise. So whether or not the water goes up or down, it's going to cost a lot of money. We don't at all allocate money to that. We just basically let it come to us.
You talked about the power of one. How do you see, I don't think there's an understanding of the situation
and you can't depend on the power of one until there's more understanding of what might happen.
That's very fair. So the one thing where scientists, and it includes people like me, have basically not delivered and have started to pick that up now, is to tell people more clearly what we really know and what we should expect. And why we didn't do that is because we're also not that certain. And there's always somebody who has another opinion. But it's like basically science dropped the ball, very much so. Since about sort of the 70s and 80s, we knew a lot more. But the politicians didn't want to listen to us, and we were fine in our ivory towers. And so the first thing part was that we understand what the changes are, but what we've also discovered was even now we tell what the changes are. There are forces that are so big that are hard for governments and institutions to change the pace. And this is why the power of one is always introduced, because now everybody knows what the changes will be like. What I gave you the stories, we give the numbers, there are good analyses, every politician has access to this. Florida knows what's going to happen. They know the timeline when these things happen. New Orleans is going to get flooded again in the next 35 years. We're spending boatloads of money on something that's basically throwing it in the water. All these things are played out. The problem is people don't change because the politicians have no inclination to make the change because it's expensive. And it will take things away from you that you have now for something you may not get because it's down the road, right? And so the power of one is said, well, wait, if you now yourself take that responsibility, think about that. If you insist on that change, if you buy better light bulbs, all of you hopefully are starting to move to LED light bulbs. If not, your company does. And you think, what's one light bulb going to do? Well, okay, 7.5 billion light bulbs. And telling people, if you individualize it, then you would start, and politicians are listening to you. That's how it works. They don't listen to science or some general talk, but they listen to people who vote and say, this is important to me, the power of one, then it will grow as a larger group. It has to come from the floor. And we've actually made the mistake to say these are institutional things we have to change. We have to help the politicians to make the changes that they need to make. They're not going to make any changes. Our favorite presidents for many people give talks for $400,000 I just read in the paper. Who thought it was going to happen? Bottom line is politicians are politicians. They have no inclination to change unless we want them to change because we don't elect them otherwise. And that's why we have to take that responsibility. And I used to think it's stupid to say a light bulb change is what matters. No, it's not the light bulb change that matters. It's that you thought about, you wanted to do that because you saw that if you wouldn't, who would? Right? And the clip that I won't show is the clip of the kid who stands in front of the big tanks in China, the one in the Tiananmen Square. Now, I don't want to go longer than you, and I'm allowed to go here, but it's this clip. You all have seen it on YouTube at some point in time. This kid who stands in these 5 tanks in Tiananmen Square, one boy, and he stands there and he stops all these tanks moving. And that's the same we see that in South America when deforestation trucks come by. Individuals take that responsibility. We made the mistake to say that it's a group decision. We're not doing anything as a group. If you individualize it, people actually start to say they move that way.
Do you have a sense of what, we are one generation, I can see this room, but you speak, you teach, and, to much younger people. Yeah. Are they understanding?
Yeah, I give them one thing I didn't give you. Because, as I said, I tune these things to the audience a little bit. So when I talk with the students, I talk about something that I haven't raised at all as values. So I'm not going to tell you what your values should be, but I tell the students that their parents' values are no good. Our values is how much do you make? How big is your house? How many cars? What kind of car? 4-wheel drive, of course. SUVs, yeah, 2. We value, have very, very set values. I tell these kids, don't listen to your parents. Ask them how happy they are. Well, I don't know. How many dollars sits in happiness? I don't know. I just have a job. The point is, so when I talk with the kids, I say, don't pursue the values I did, and your parents do. And by the way, the kids remind me, I'm actually their grandparent now. It hurts every time they remind me of this. But so I talk with them about something we call the Great Transition, which is another term. I took it off the slides here. But I tell them that you cannot pursue the values that the generation of your parents has, because they were post-war children, post-Second World War children, safety, owning stuff, salaries. That's how we measured happiness. Are people very happy? I actually don't know. Young people seem to be actually quite happy. And the new generation of young people, if you have children and grandchildren that age, they live very different. They are in their 20s. They no longer pursue that house when they're 22 and married when they're 23 or 24. They still live like students when they're 28 or 29. And they sort of have relationships that are long-lasting, but not necessarily with marriage. With them, I talk about follow values that are not monetary. That is probably the first path forward. Then you worry more about the environment, because if you have a lot of money but you can't breathe, meaning living in Beijing, what's the point? You might as well be poor and not breathe. Or maybe you should have, money is not important, but we have a good air. That's the value. So I talk the value part with the students. So I have the last slides are different. They are about what we call the great transition, measuring happiness, measuring what you value out of life. And it's not a bigger house, but in this audience, I'm not going to tell you your big house is basically a Fata Morgana, because you get angry and say, who is the speaker? And my house is too big. It goes, and I drove in my convertible car here. I had to top up because it was too cold, but I'm a child of my own generation, but I go with values. You do, but I think at this stage, but you can only give so much a story. What you haven't even heard enough, now you do, of course, it's really what we know a lot what's going to happen. We just didn't talk about it that way, because we can tweak the numbers a little bit, but the patterns are the first thing to take away. So the lithium I always bring up, because it's, for me, that's also a revolution. I mean, for all of you, of course. When we do technologies, we don't really scale them up very well. We don't realize there's not enough lithium to power the world with lithium batteries. And by the way, that's why they're developing zinc batteries and the like, and different. That's what we've always done, because you're old enough to know that you had nickel cadmium batteries in your first phone. Remember, your phone would do it for 2 hours and it was dead, right? And of course the signal was poor, but you had your little Walkman, the little giant thing on your belt when you were a kid, you know, sort of the DVD player. Yeah, we're clever. See, that's the thing. We're not passive players, but we need to understand the decisions that we make. We need to play them forward and realize that these resources are still limited in some ways. And they have a price, but also a price for all of us, not just for those who have. The have-nots also have a price. Lithium makes Chile rich at the moment, but at a great environmental price. We'll go to other batteries. And why do we do this, by the way? Is because we are realizing more and more that if you look and you play this out, there's not enough of it. We have to go in different directions. We don't like change because it costs money. Would you buy a cell phone that's $1,200 with a different battery? Probably not. You'd probably say, no, I'll buy the one that I have, which is $600. It's crazy, by the way, anyhow, you pay $600 for a phone. I mean, it's just ludicrous. They really got us by the rope there. But no, you won't. But that's, of course, what governments are supposed to do. Governments are supposed to invest. We have ARPA-E, which is this program in the government that is crazy energy programs. Try different things. Put some money at it. Yeah, it costs money. It may never go anywhere, but it does go somewhere. Putting a man on the moon really had no particular reason, except that all of you rely on that technology now for anything that we do, including driving your car. Basically, investing is what governments have stopped doing. They have the money. That's our money, of course. We should insist that they spend that money that way. But there are alternatives. We're smart. The problem is you can't be in your garage anymore inventing something smart. The technologies are so complicated that you need larger outfits. You need institutional structures. This is where our politicians are falling short. They basically don't see value in supporting science and engineering, because things work until they stop working, and then there's another guy who's in charge, right? But we are smart. We are incredibly clever. No, we're only getting smarter. That doesn't. We still have to live in the planet that we live on. So if you make our environment very complicated, how smart we are doesn't really matter. You have to deal with that. But we're clever. We find ways. I always give this food story. I grew up hearing that food was the biggest problem. I'm going to be hungry when I'm in my 50s or 60s. Well, I'm not hungry. Well, I'm a little hungry now because I only had a sandwich. But the point was, we're clever. We found solutions. It's amazing how clever we are. It's just that we need to think about the implication of the choices we make should be more than just to get something that we want. Is to realize, is it something that we need? Is it something that's a value? And happiness, there's no machine.
Involving AI into the future where we won't even need humans at all.
Yeah, I'm not much an expert on AI, artificial intelligence. there's a lot of debate on the papers are big on it at the moment, and of course, that mostly relates to engineering at the moment and how it takes over positions and jobs. But yeah, no, hey, a plane is smart. The plane knows how to fly. I mean, we just steer it. We've always relied on technology. But yeah, there's a price for that. That's unstoppable, by the way. The machines get smarter. And all of you, of course, seen your science fiction movies that the machines might take over. Yeah, who knows? And we might be those machines. Remember, we've only been on this planet as sophisticated as we are, at best, for a few 10,000 years. Humans have been, of course, the human species has been around for 7 or 8 million years, but Lucy walked around on our planet not very smart. I mean, basically, he was essentially scavenging for food. We've been smart for a few thousand years, perhaps. Imagine what 4,000 years from now would look like. How far we got in these last 2,000 years? Who knows?
And maybe for the last 10 years.
Well, exactly. And so this is why I have this acceleration plot up there to show you that in 100 years is easier, is that how much things have rapidly changed, yeah. And faster than we can control. But again, we are not stupid. So the one thing I always say also to the students when I talk with the kids is say the mistake that you often hear is that we are passive players in this. We're just sitting there and the water rises and we just don't know what to do. Of course we know what to do. It will cost, it's an investment, we have to think about it, we have to make plans, but we're not going to simply sit there and drown with the water rising and rising and rising. We'll stand up first, or we build something higher. And so that is always the way humans are. We're pretty clever. It's just there's a lot of us, and the problem is that the growth is in nations that have no resilience. So all the growth in population will take place in nations that have no ability to take any change. In fact, they need all the help all the time they can. Water access, food access. That is a bit our responsibility because we used those nations to get where we are today. That is the difficult part, that's the sensitive part in this. And you don't talk with people in developing nations about, what's your happiness status today? I mean, no, they like some food, please.
Do you see us being
Go ahead, no, go ahead.
clever enough to have enough water in Africa? Because, I mean, it seems so...
So there is no reason to assume that we can't have a great anecdote. One trick that people had done earlier, 20, 30 years ago, to take icebergs from the North Pole, drag them down to Africa. You think, well, that's pretty stupid. Actually not. If you ever drop an ice cube on the floor, it's really annoying. That stays there for 10, 15, 20 minutes. You take an iceberg, you can haul it down. The Saudi Arabians did it in particular. They had lots of money, of course, and they can do that. That's not a clever way to go because you lose about half the ice as you drag it around, and you need a boat to pull it around. But there's salt water, and salt is, you can take salt out of water. What you don't want to do is build a power plant using fossil fuels to get the salt out of water. But if you evaporate water, the salt stays behind. The evaporation. If you ever get stuck on a boat on the ocean and you are getting thirsty, just put a little plastic cover over the ocean water, let the evaporation get the plastic cover. It's all fresh water. Salt does not stay in evaporated water. If you evaporate it with alternative energies, yeah, you can do that. But somebody has to give these nations the money to build that infrastructure. That is the problem. And that's not cheap. But yeah, absolutely, we can. The problem is a little bit that because of climate warming, those areas will be under even greater stress. And so you end up with it may not be the best place to be. It's a horrible thing to say, but it may not be the best place to be. And living in Arizona only works because we have a lot of money. But if you would have to live in Arizona in a tent, you wouldn't last very long. It's not great weather. You have no water. We just have a lot of money, so we force our environment. It's hard to force the African environment. There's too many people there, and it's going to get harsher conditions. It's the Sahara. It's the desert. It's Las Vegas. You know, it's the desert in Las Vegas. There's some sand somewhere that somebody preserved. Am I supposed to stop? I mean, I'm here. I drove all the way up here, so I have time. I like to talk, but okay. Go ahead, sir.
Oh, me?
Yeah.
I just wanted to say, if you drive along Interstate 8 through southern Arizona, in the distance to the north, you will see the big pipeline. And along the road, you will see people growing rice in flooded fields.
Flood fields, yeah. Well, that's of course the fact of our infrastructure that that is the problem that our kids have to deal with, that the infrastructure is also aging, what we deal with. I mean, that not just water infrastructure, oil infrastructure, the pipelines, the grid. How many of you were out of power? I was out of power for 3 days where I live. And why? Because some tree snapped the power line. Our infrastructure is not very strong. I'm not even talking about the potholes, which already is an embarrassment, but it's just anything else. Yeah, it costs a lot of money. Well, but it works. And so we'll leave it, because you don't pay that price for the leaking water. Water is cheap till you pay for it.
You're a pessimist on alternate energy. There's money in alternate energy. There's money in wind, there's money in solar, there's money in tidal, but there's especially money in wind and solar. And there are people that are going to make money in it. There's enough wind in the Upper Peninsula to put in wind turbines, and you can make fertilizer, even if you can't build the power lines. You'll never get the right of way to build a power line from the Upper Peninsula.
Yep.
Everyone is going to worry about getting leukemia from the power lines. But you can build plants for making ammonia there.
Yeah.
I mean, there's all along Interstate 10 in California, you're driving through 180 miles of desert. There's enough photovoltaic area there to take care of the entire country.
Absolutely.
Just enough. Within 20 miles of Interstate 10.
Yeah. One of the calculations I do when I teach a series of classes on this, I'll calculate out how much you need. You can power the entire world's energy need with a small set of wind power, and with a few solar cell farms. Few still means the size of sort of a quarter of Nevada or something like that. But absolutely, the thing is, we haven't moved. This is what is the irony. I've been talking about these topics since the 90s. We have not shifted much of our infrastructure in capitalizing on that. And that is what my frustration is, that we know we can, but we haven't. And by the way, who's going to make it happen? It's going to be Shell and Exxon. Why? They're rich. They know this is coming. It's not worth it them to keep getting oil. They invest in that, and Shell and BP.
Well, let me tell you about this. About 25 years ago, I spoke to a good friend of mine, who at that time was the vice president of BP, talking to him about the oil shortage. He said, "What oil shortage?" There's no oil shortage. I said, God, I drive through Texas, I drive through Oklahoma, I see all those pumps standing still, they're not moving. He said, what percentage of the oil that is recoverable with today's technology, and that was 25 years ago, what percentage of that oil do you think is still in the ground? And I said, 20, 30%, try 98.
Yeah, well, that's the problem.
He said, but what? So I say, so why don't you get it? He says, because it's cheaper to get it in Saudi Arabia, where it comes up by itself.
But that is the problem. We know there is so much fossil fuels, and it's so much easier and cheaper, and that's why we haven't really budged in that direction.
There's no shortage.
No, I know. No, by the way, geologists have always have told these people. We didn't tell politicians.
The desert has enough to keep everybody, and if they run out of it there, it's more expensive, but they could get it out of the Great Salt Lake, and they could get it out of the Dead Sea.
Yeah, so if you like bumper stickers, one of the things that I also do when I talk with students, I give them something to take home to think about. I always say, we're not running out of energy, we're running out of environment. There is enough energy to power the entire world many times over. The way we're powering it has a big price to pay for the environment. That's what we're short of.
Well, there's one thing that global warming is going to give you a little advantage of. If you look at any map of the world, the globe, you will see that there is much more land in the northern hemisphere than in the southern hemisphere. All through Siberia, all through northern Canada, there's loads of land, which are now frozen, or at least partially frozen. It's going to warm up. That land can, in 20, 30 years, be arable.
Definitely.
And as I say, yes, you're going to lose land. You're going to lose land in Bangladesh, where you're going to probably have, I don't know how many millions displaced. Probably more people will be displaced in Bangladesh than anywhere else.
Mm-hmm.
Florida, they can afford to build taller buildings. In Bangladesh, they can't.
Well, that's the message, right? So what are you willing for which price are you willing for people to pay for this? Yes, there are 50 million people in Bangladesh that will have to be relocated by 1 meter sea level rise. 50 million people.
Unfortunately, when Miami gets flooded a couple of times, the money will be there for the research. Just remember, we lost our two biggest research engines were lost. Union Carbide and Bell Labs, the two biggest sources of what can I call it,
Innovation?
scientific research. Where in both labs, just do it. If something good comes out of it, great. If it doesn't, well, you'll publish and it will be of Mr. Dr. So-and-so of Bell Labs or Union Carbide. They're gone. Bell Labs is shrunken down to nothing, and Union Carbide is completely gone. Those are the two biggest that we had. IBM is still existing, but they don't do that much basic research anymore. And most of the research that we're doing now industrially is the expensive stuff at the end, trying to refine something a little more, to refine it, to refine the software a little more, to try to get a finer line on the chip.
No, I'm gonna argue with you. That's not an attitude to take. 15 years ago, there was no internet. Come on, there's not been a bigger revolution than your internet access. Would you imagine not doing that? So we have done innovations at a spectacular rate. It's just as what I talked about was the fact that we didn't make infrastructure changes that we could make. That's all I was trying to point out.
Internet came to you courtesy of the military.
It's always courtesy of somebody. It came to your tax dollars.
Yeah,
You paid for it.
I'm saying that the internet was initially built by the military.
Yeah. But the point being that we have the ability to make change, but we haven't done as much change as we could have. That's what I tried to point out, is that now you talk about nations that need help, that need support. They basically are not going to make any change. They're going to go in the route that they do. But yeah, alternative energies. I don't know how many of you have solar panels. In fact, I just paid for the contract on my rooftop. Why? Because I felt I had to. I will never make that money back. It's really probably, I'm not even sure it's a smart investment in the sense of environmental, but it's a step. It's the power of one. Probably my neighbors do it as well then, if I do it. That's kind of the way I think about it.
Well, we've heard a lot of lectures and stuff on alternative energy, like China right now going big time in solar. And I think I told 2030, 35, they're going to be off solar because they include their
Because they can't breathe in Beijing.
product development.
Absolutely.
They're more in alternative stuff
Yeah, well, that's what sort of...
The biggest setback is they need to increase the storage capabilities. That's going to be their end in the micro communities that's being developed.
Yeah, as they always make the joke, there's no sun at night, but there's storage capability. No, absolutely. It might take place, but it will cost money, and they're not going to give it for free. And basically, that's what is the concern. But we've been saying this for a couple of decades already, and it hasn't really budged very much. Even in China, they do it only because of pollution. It is just not possible to be in Beijing, and they don't do it because they think it's the way to go. The coal is simply not going to be a sustainable source of energy for the Chinese, and that's why they do it. It's going to be very expensive for them. It's hard to generate energy for 1.2 billion people actually that way. But yeah, you had your hand up.
On the issue of global warming, the computer models that we've seen over the years and the actual numbers, really
Yeah, that's always the question about what do we know about planning the future. So here's a trick that we do. So you build a model, and before you laugh, you'll see why we do this. We predict the past. If our model is able to predict what we know about the past, then we have some value in predicting the future. Now, that tells us that we can give you a pretty good sense what happens in the next 100 years. But you don't care. I don't care. I'd like to know what it's going to be like in the next 10 years in Michigan, or better yet, this year, or the growing season. That the models can't do, because weather is not climate. Climate is the integration over long times of weather. But what we do is we take these models and make them sophisticated. We see what we can predict from the past. If we can match the past, we can then basically predict the longer term of the future. What we're doing today, we're scaling this down to smaller areas. So today, every government has information from these large models what their nation, if it's a reasonable sized nation, should expect. In the US, of course, it's not a single nation, it's all highly regional what these effects are. It still remains a projection, and it's always a projection that is more than a few years out. It's what would you expect the next 50 years. When eyes glaze over, if you're a politician and you hear and we tell you, the next 50 years expect this, what about the next 4 years? That's because we are basically allowing ourselves to be driven by a cycle that is not natural cycle.
I guess maybe my question is, I was under the understanding that the rate of change of global warming would actually happen quicker than the models were predicting just a short while ago. Is that true?
So the models, you can do anything we do with the model. The problem we didn't have was to see how nature was responding, because we've only doing this experiment since about the mid-1950s. Or 1945. And so by the time we started these models, by the way, the computers were simpler too, but we had about 20, 30 years of observations. It was not a whole lot. And if you look at these people who do the modeling, they say, it seems to fit that. It took us a while to generate the data to actually get that real-looking prediction part of it. We do not have the exact details. We don't even know what the sea level rise will be like, because we don't control these things exactly, because we don't understand clouds very well. And this is the problem with scientists. There's always something we don't understand. The mistake we've made is that we forgot to tell you, but we understand enough for you to think about this. Just because we don't all understand it doesn't mean it's not going to happen. The reaction is, if you don't understand it, it's probably not taking place. No, we know it's taking place. The scale is not always well known, but it's getting pretty clear. But still, we can't tell you how much sea level rise will be by 2050, because we are startled to find out that the ice is melting faster on Greenland, but it's not melting at all in Antarctica. It's because climate takes a little while longer to adjust. It's kind of tricky to get the scale.
But it just seems like there's like two schools. One is it's a hoax. The other one, or the scientists are just trying to get research money. And then there's the other one that it's, this is really an emergency that we're not taking seriously. It seems to be worse than what we thought it was ever going to be.
Yeah, and I wonder how that happened, that we got to this debate whereby it's like it's either a hoax or it's the people that are trying to line their pockets. We did something really stupid as scientists, because first of all, if you want to make money, you should not become a scientist. If I would have worked for Shell, which is my other job offer, and not being a professor, I would have had a bigger house and a bigger car, and I would have been much happier. Oh, wait a second, I'm not sure about that. No, and so, yeah, that was just an easy way to sort of peg one group against the other. The problem with science is this, and science was that these things were so fast, this acceleration. So it's like when you drive a car. If you drive at a certain speed, you know how you get there from point A to point B. If you do this with an acceleration, you don't know. You have to figure out how much you're going to accelerate, then you'll be there much quicker. We have not grasped the acceleration, and we hadn't appreciated that the acceleration rate is so high, and we see that now. Yeah, is it a hoax? Look around you. No, but I'm saying you're saying it, but I mean the mistake was we got ourselves drawn into the discussion just because we don't know the exact implication. We know that things will be changing, and if that's okay with you, then let the change happen.
I guess you're still not getting at the crux of the question. is that what we're seeing today with the rate of change, say going back maybe a couple of years or 5 years, and what they're actually seeing that the models were predicting like 5 years ago, and what we're seeing today, it seems like every year is hotter and hotter and hotter. We're getting record after record.
And the CO2 level is.
But we cannot predict 5 years. That is simply what we should have just come out clear with that. At best, 25 years is a window where we can predict things. 5 years is not the way to go. A few years ago, we were in what they call the atmospheric pause, which is a term that the New York Times liked a lot. It was a window of time where the Earth, on an average, did not heat up very much, a 5-year window. That was, of course, great ammunition for a lot of people to say, see, nothing is happening. We just said, well, but it's a natural system. It will adjust because it will suddenly adjust. And the last 2 or 3 years, we saw a spike that's much hotter that made up for that pause. The problem is our models don't show that because our models are not tuned for 5 or 10 years because the atmospheric circulation doesn't work that way. We don't predict the weather. We predict the climate. And weather is a day-by-day, week-by-week thing. But, the weather predictors don't do very well 3 days out. The climate people don't do well 10 years in. That's just because of the dynamics of how the system plays out. So no, we can't give you that prediction, but we can tell you what you should expect if it goes on like this 25 years from now. That should be enough of a worry because you have kids who have to live in that world. And that's the mistake perhaps scientists have made, is we try to give more information, but then we realize the parameters of uncertainty were so large, and we got roped into the discussion weather versus climate. You should never use weather as an argument for climate change. It's a big mistake. But it's been hot lately, and I showed the picture, the warmest decade ever. I used to first teach about this. It was not very popular. I used to have a course called Sustainability, which is the only course on my campus, University of Michigan, one course on sustainability. Now every course is called Sustainability, but that was a new thing. We had very little to go on. We had some climate records. There were some, but there was no really good numbers. This is 20 years ago. That's what you had to deal with. We decided to invest in measuring observation and try to test it. We still can't get our models down to smaller scale because the dynamic of Earth doesn't work that way. Earth does not go by you or my timeline. The question that people ask when I give another talk is about earthquakes. Why can't you predict an earthquake? I can predict an earthquake really well. But you're not happy with my answer because I'll tell you within 100 years this will happen. That's not what you want to hear. But the Earth said that's perfectly good to me. The Earth, 100 years is nothing. And so it's the time scale of the system that you cannot tune further down because we're not predicting the weather. And that's just the limitation. But luckily, or not, the bad news is we see sea level rise now. We see more storms. We have more water coming down. We see the monsoon is cycling differently. Suddenly, nature is catching up and giving us all of the information. We're cautious not to over-extrapolate that because we still cannot go down to smaller scales because the natural system is based on a year cycle or multi-year cycle. We should probably draw this to a close, but you haven't heard you yet, so.
A question about population change. You mentioned that one of the three things is fewer forks, thinking about the great acceleration, thinking about the rate of change is going down, but I'm wondering if, let's say, the population does continue to increase at whatever rate. If you don't reduce, essentially don't reduce the forks, but could you talk about the couple things that would have to change if we don't reduce the number of forks?
Yeah. So what I showed you was just a calculation of population change as we see how the trends numbers have changed. And what we all know is that every now and then nature throws us a fastball that we didn't know. And there's an increasing realization that because we are so delicate as a species, there probably will be some sort of a global thing that will wipe half of us out. I am not sure, but it has always happened in nature. It has always been. No species was protected from nature because nature has its own system. And so predicting the number of people of population in a short window is entirely based on what the year before and the small change you can accumulate. But it doesn't take into account that diseases might take over. And we've had a few scares, right? A few ones that we were worried about it be a significant scare, but it turned out not to be too bad. Something will eventually stick. And
yeah, but your numbers like were 9, 11, 13 billion, all in kind of 100 plus years.
Yeah, 11 billion by the end of
If
the
you think of like 5,000 years out, what sort of things make acceleration happen?
It can't grow. Yeah, no, it can't grow. So no species can be, well, that's not entirely true. Maybe we are different. Maybe it can happen for us. Maybe we are smart enough to do that. But it's not how it naturally typically works because we're still organic beings. We still have, we're organisms. We're carbon-based organisms. There's a limit to basically what we can do. Yeah, you can multiply the numbers 5,000 years out. So demographers point out that the end of the 22nd century probably only has 3 or 4 billion people. They just think it's not sustainable because of illnesses, of how we live. We also tend to kill each other. It's kind of one of the things that we do. Some disease or killing, that's what we do. Yeah.
And we have to have enough environment to support it.
Well, exactly. Yeah.
We're not.
Yeah, but we're awfully clever. It's amazing that we got so far. But a small disease might take care of it. Bacterium, remember that it doesn't have to be a disease that's present today. Just like we are slowly evolving, other organisms are rapidly evolving. They probably see us as a great ground for food, like we did with other species. So going far out, really, it's not clear, but we might be surprised. I look at science fiction movies with the same reason. They say, well, what the future might look like. But demographers think that will be a limit that we probably won't grow even to the 11 billion, mostly because of what sort of human history has been about and the fact that you cannot all be elevated to the same high standard of living that we are in the Western world for the 9 billion that we predict for the middle part of the century. But how it will play out? If you think climate modeling is tricky, imagine population dynamic modeling where you have to deal with people. All right, I think we should wrap it up. Thank you so much.